Hello, my name is Paweł Ściborski and I will tell you about using AI for the threat modeling because I'm building application that helps engineers with that. And yeah, why would you trust me? Because the topic is a bit about the security. So I have worked at the Intel here in Gdańsk next to the airport, and I was like product security engineer, and I helped to secure some software used in data centers. Later I worked also at GSK, it's like pharmaceutical company, where I have introduced the threat modeling to some company systems like for the management and expedition of like medicines. And I was like also a few times a founder of a startup. None of this was like multi-billion-dollar company, unfortunately, but I really recommend like doing something in your time and maybe don't like drop your job and go 100% into that. Maybe build something on your own time, and it's really like fulfilling if you will find someone who wants to pay you like even little bit for problem you solved. And yeah, and you can make some money. So yeah. Okay, so now I am building Armeiro, which is a tool for automating threat modeling, at least partially. And first, maybe I will start like telling you about what is the threat modeling and why it's important. Then I will go like what are the challenges, and then I will like tell you about some tricks and tips in using agents, not maybe only like for threat modeling, but how I am using them, and these things can be like useful for any other like agentic applications. So with threat modeling, like the most basic thing is like 4-question framework from Adam Shostak, who is like evangelist of the threat modeling. And there is like a lot of like frameworks for threat modeling, but this guy like decided, okay, like everything like comes up to these 4 questions, like what we are building, what can go wrong, what we are going to do about that, and did we good job. So going from that, we can like broaden it a little bit. It's like a structured way for building architecture for application, like to understand the logic of application, what can go wrong, and any mitigations for that. And usually in perfect situation, like you can see on this, can I click this? Okay, doesn't matter. Like on this slide, like you should do like threat modeling some more like around our requirements and architecture when you design your application. And this is like in ideal world, because this way you can prevent vulnerabilities, not discover vulnerabilities that already exist. So it's maybe not so trendy like pen testers that will find like vulnerability in Chrome web browser, and they will get like a lot of money. But for companies it's important because it can save money, because fixing bugs later is much more expensive. Like for example, let's say you are like hardware company and you are selling CPUs, and there's like security bug in CPU, and now your customers want your CPU back. But this also like applies to the software. Just in software, it's maybe a little bit cheaper to just produce the patch. And yeah, so with threat modeling, we are not only finding vulnerabilities, but we also like understand where they come from, what can go wrong, how to mitigate impact of the things that we didn't find yet. And Okay, maybe I forgot one thing. I talked about the ideal world, perfect situation where we do threat modeling early, but more often it happens like we have already application, and okay, we cannot prevent vulnerabilities, but we can like still find issues within application, but we need to fix them, and cost is bigger. So okay, so it's like a foundation for secure software. Like you can see on this pyramid, scans, pen tests are like something we do at the end. And before that, we put like any security guidelines. We keep best practices, and even earlier we try like to understand what the application have to do and what can do and what is like allowed or not allowed within the application. So one of the common things that we do with the threat modeling are data flow diagrams, and we do that with most of the frameworks for the threat modeling. So we gather like there like everything like what are the data stores. So it can be like database or maybe a file, and what we keep there, like maybe it's like user personal information, passwords, and these are like security assets. And there are like processes, so application that process like data, and maybe some external entities like users, like administrator, or maybe a hacker that want to break into application. So there are like multiple like threat modeling frameworks, and depending on what you want to do, what you're looking for, like the most popular is Stride, which is spoofing, tampering, repetition, information disclosure, elevation of privilege, and deniability. There's like Lindun, which is like used for more like for privacy things. Pasta, which focus more on the what attacker can do. Octave which is more like for organizations. For example, Maestro is like for agents. It's quite modern framework. So what we do, we apply these threads like to the data flow diagrams. And for example, and how we do it, like for example, let's say our asset is in this library is our tracking of the fees for late book returns. And let's say attacker want to try SQL injection to remove his fee because he need to pay like 20 zlotys for that. And if this fails, maybe he want to impersonate librarian, maybe he will steal his JWT token, or maybe he will like forge his own JWT token because there's like issue with an application. And also attacker can just kidnap the librarian and like torture him until he will tell everything. And yeah, like often like for some reason like companies don't want to like talk about these issues, but you can like do threat modeling from just software to whole organization. And things like social engineering is also like in the scope, and a lot of attacks come out like from this social engineering. So later what we do, like for each threat we found, we look for mitigations. Like for SQL injection, we use like parameterized queries, which is like correct answer. But what if for some reason we have agents that forgot to like do this, and we are like doing everything with cloud code? Or what if we have like intern who decided like, okay, maybe let's do my personal framework for querying database because it is so cool. And so we add more like mitigation, and we can like use like separate permissions for for some tables in database, or maybe different kind of permissions, like when user access like our application, it communicates with database only using like read permissions in database. And going like this, we can use like adequate flags on our cookies, so nobody steals tokens. We can like make tokens short-lived, so like duration when they can be like stolen like is short. We can pay for bodyguard for our librarian, or we can just decide it's like accepted risk. And that's usually what happens, like if it's like library, but maybe like for some banks it's like important maybe to protect your director or maybe like CEO of company. So what AI brings here? So it can process a large amount of input, and this input can be in different forms. It can be like unstructured, and we can like create structured outputs. And these are like things that human can do also, but AI can do it like really fast. And unfortunately, it's also expensive. Okay, and what are like AI limitations? Overconfidence, hallucinations. These two are like kind of related, but I put them like separate. Like from what I see, like AI often like will provide you solution that is like correct, but maybe if you dig more, he will say like, okay, I found like this one like vulnerability here, but there is maybe more, and your agent won't like ask questions. Okay, if there's like anything more, there are like hallucinations, so agent can like tell things like are totally not true, but he will be like totally sure like these are like true. There's context creep. So the longer is conversation, the context fill up, and the answers are worse. The agent is like performing worse and worse, and like outputs are not so like useful anymore. And there is also lack of explainability. So our agent comes to us, say something, and we don't know why he decided like this answer is like correct. It can be correct, it cannot be correct. Like we don't know. It can be like either way, but we have no idea how the agent like come to this idea. So what are like the problems also like within the threat modeling? So threat modeling should be done like early when we are still working on architecture and requirements. And this is like kind of also a challenge for me to build this application in a way that it's not another automated pen testing tool, but something that can be useful early. And other problems, often developers skip totally documenting architecture, and like myself, like I had like even this situation when I, as security engineer, I come like to developers and okay, we need to like do the threat model, like help me understand what's going on in this application, and the developer just said, yeah, the code is self-documenting, and I don't have like time for this. And this is I would say really not cool, and I don't like this guy. I mean, I know code is self-documenting, but if you don't write the code in this language, you don't know much. And there's also another issue. Okay, even if you understand what code do, you don't know what code should do. And these two things are not always the same. So another thing is code often doesn't carry information about the infrastructure and organization where it's deployed, like whether it's like deployed to GCP, to AWS, if there is this librarian that can be kidnapped and ask for the password. You don't find this like things in code unless maybe there's like Terraform files in the code, but sometimes like people like will put things into the cloud like manually or so where LLMs can be applied. They can be applied like to applying the threats. to architecture and code when we have like this architecture, and it's possible. Okay, we can like check if the application conform to the threat model that was done before, and we can also build architecture in reverse from existing code and documentation. And what would be like fastest approach? Let's like take this shop. It's like OWSP application, like it's on purpose like vulnerable application. And there is like over 100 like vulnerabilities for people like to learn how to exploit them. So let's put that like to the chat GPT. Let's see what it does. And you can see there's like some architecture diagram, but it shows like there is MongoDB in this. There is like Redis, there is email service, and the reality is like there is none of this like in the juice shop. And there is like non-SQL database, but it's MarsDB. For some reason, like I don't see even SQL database, which is also there. I don't think there is like SMTP service. So on the first like look, it looks like okay, maybe lagged, but if you go like further, it's not. And then you have like some like threads and examples to what is the impact, but we don't know where it comes from. We don't know like in what part of the code like this really like applies. There's like some data flow diagram, but it breaks for some reason here. This is like ChatGPT. I tried this also like with Claude Code, and Claude is like much better, at least at the understanding architecture, but not so good at applying the threads. Okay, and going from this, I will like tell like some like tips and techniques I am using, like developing this agentic application. And first few are like related to the prompt, and it's not like I need to write all the prompts myself. Sometimes I can use like AI to write prompts or enhance prompts. So when you are like writing this prompt, instead like asking like in this general way, like, oh, are there like any vulnerabilities? Like try to like ask us directly about these vulnerabilities as possible. So if you can like point out about the concrete like endpoint, like path, whatever, it's you will get like better results. Then like try to explain what to look, because maybe your like first like question what to look for is a bit like too simple, and so like try to explain it more. And then you can also add like some examples. So here is like kind of like questions agent can ask for, like finding RDOS vulnerabilities, which can cause like DOS issues where like it will hang like your application. And like recently using my tool, I have found one in some open source application, and I hope to get like CVE for that. So, and another thing is structure outputs. So if we measure like agentic frameworks like LangChain, LangGraph, and ADK, and I'm actually using ADK as the presenter before me, and these frameworks support like some way of structuring your output, either like with Pydantic or JSON schemas. So if you tell like your agent that, okay, your data store can be like either database or file, You won't get like, I don't know, cloud storage here for some reason. He won't hallucinate. He will like choose like either from these two. This is maybe a little bit simplistic here, but if you try to structure like your output into things that you want, like you expect, the more likely you will get like the things you would like to. And it's like later also useful because you can put this structured output somewhere else, like into your application. Another thing is retrieval augmented generation, so-called RAG. Well, I'm not working with agentic AI so long. I used to work before, like from my previous startup, maybe with generative AI. So RAG wasn't so useful. So like if it wasn't useful, I didn't care. So actually, when I heard first time about this, I've seen like, maybe not I heard first time, but like I got like interested. It was because somewhere like everyone on the LinkedIn like started spamming RAG is dead. Why? Well, like if you look like at the definition, it's like just enhancing like the prompts with some input like from the from outside of the agent. So at least that's his definition on the Wikipedia, and it's cool definition. But if you go like to any like tutorials about the RAG, the first thing they will tell you is about this vector RAG, and apparently this is dead, but it's not true. So how it works is you take a file, you need to chunk it. So for example, if it's code, you can like chunk the files by the function, classes, maybe on the lower level by ifs, and from that you can like you do something. You use something called embedding model, and embedding model transforms your chunks into vectors. And these models also have this issue. They are like not so big as the main models like Claude or like Sonnet or Gemini or whatever. So they have like quite limited context. So you cannot like put into them like too big class. You need to like chunk it. And if you have this embedding, you store into like your vector database vector together with chunk, and later when it comes like to the query time, your agent can ask for something, like generate like question what he is looking for. This question is like transformed into the embedding model with embedding model into your vector. Then your database is queried with this vector using vector similarity algorithm, and it retrieves data, and in that data we have like both like the vector, and the response is our chunk. So this chunk later go like into the our agent and can enhance our prompts. And much simpler things, and this is how actually like Claude Code works. It's like file system-based RAG, and it will like have just agent, and he will like just list files, read files, grab files, find whatever he needs at the whatever moment the agent wants. And honestly, this works much better than this previous solution. But there is like one caveat, like we can save money with that because we don't like use so many tokens. So for example, in my case, for my application, when I'm like scanning like whole applications, like let's say almost like every like file with code, I can like put this into the RAG and save money like on later processing data from these files. So because my agent can like query like rack and like get the information straight away, he doesn't need to like put into the context whole files, whole data, whole structures of the file. And then there is like another one rack I am using, or maybe now a bit experimenting, and I think it's like really cool and promising. It's graph rack. How it works? So you have like your code. The code is transformed into abstract syntax tree. So it's kind of like code in universal description and there's like a lot of parsers for different languages. The parsers I use are like called tree-sitters, and then from this abstract syntax tree you extract all the imports, calls, function, whatever you need, and or whatever relations between like different files and parts of the code. You save that into the graph database, and later at the query time you have like orchestrator, which will generate, will decide like first what to do, because maybe he wants just to read the content of the file just straight away, but if he needs like any relations between like files, between like functions, variables, he can generate like a Cypher query. Cypher is like SQL language, but for graph databases. And graph database returns results. Our orchestrator translates these results into the natural language, and it can like enhance the query using that. And sometimes also like orchestrator can query things directly, and also you can like combine all the racks together and like put like orchestrating agent that will just decide himself like which tool with which rack he wants to use. So next things are like some patterns you can use. So for example, evaluator pattern, or it's a critic pattern, and maybe like there's like some other names for that. Like you have like first agent, he will like query your source code or any documentation, because you can also like submit pictures, like if someone have like diagrams or whatever, you can also submit to my tool. So first agent will like check something in source code, let's say, send this information to the critic, and critic will check that again and will decide, okay, the validation of that failed. And there is like another variant for that. You can like do it like in iterative refinement pattern, or also called feedback loop. So you can ask the same query like in few iterations. Okay, is it good or not? Like, and I found like vulnerability here. Yeah, I don't know. I don't think so. You can make this loop like few times until like critic agent decides, yeah, it's okay, and we can like send it out to the next agents. And another tip, evidence. So you ask your agents to provide like their like reasoning, way of thinking, and or like evidences how he come up like to this answer. And it's also useful like with these previous patterns, because for example, critic can like verify himself. Okay, there's like something in there's vulnerability. He got like evidence where this vulnerability is, and critic can check and say, okay, yeah, indeed it is there. So that's it. And if you have like any questions, feel free to ask. Yeah.
questions? Thank you, Paweł.
Okay.